Hi, very good evening to all of you. This project is about estimation of appropriate performance linked bonus, and it is little unconventional because it's true that we use such techniques in real life, and in fact, this project is inspired from a real life project only. But honestly speaking, this is unconventional because what we are trying to do here is to convert the performance of an employee, in terms of cash flow. So the data which has been given to you has those conversions already made, and then you have to use those cash flows in order to set up an equation of value and declare a bonus rate. So I hope you have tried this project so far and you have tried to generate those cash flows using a random distribution. So first I'll explain what is this project all about, and then I'll show you a possible solution using Excel. And then, if you have any questions, I'll take those questions as well. So to begin with, this is some explanation about the project, and you have been given that it's a software corporation, and the efforts of employee, to generate the revenue for the activities through the activities has been recorded, and they have given some cash flow value to this. So this is the past performance which has been converted in terms of money, and this is for all the employees, some 14,000 I guess, 14,000 plus entries that we have. So if he has been absent from the work for more than 5 days in a month, the past performance has been indicated as zero. So there has been some method to quantify their performance. We need not worry about it. We only understand that this is some form of cash flow which is given to us, which has been linked to the performance of the employee. Now, the company wants to use this data to build a model to assess a performance-based bonus rate, and because they have been the employees have been involved in revenue generating activities, so there are some expenses as well. This could be the salary or other overhead expenses. We need not worry about that because we have been given that the expenses have been considered to follow a gamma distribution. Now this is a language that we understand. So a gamma distribution with mean 1354 and variance 753 is the information that we need. So using this, we need to reverse engineer and calculate the random values for such expense variable using the variance of 753 and mean of 1354. Now this is something which you have done many times while studying for probability and statistics as well, and you know how to generate the random values from the parameters. So that parameter generation could be manual here using the mean and variance value for gamma distribution, and using those parameters you have to generate the random cash flows which are for expenses. Now there are many functions almost in all software that we are using here, be it Excel, R or Python, to generate these numbers once we know what are the parameters for the distribution. So this is a part where you use your understanding and knowledge about the gamma distribution, and then once you have these cash flows, identify the net cash flow. So you have a revenue cash flow given in the data table, in the CSV data, and then you have generated random values, which makes this whole net cash flow as a random cash flow because random value has been subtracted. Then there is other piece of information which is given to you about the stochastic interest rate, and it has a log normal distribution parameter of 0.075 and 0.01, and this rate is annual growth rate. So the interest rate distribution is known. We have studied this in CT1 or CM2 before. So if you have not seen, if you have not studied this stochastic interest rate before, I suggest you go to the LinkedIn group. I have posted a small video there which explains the idea. You can also refer to your acted notes and you can see how stochastic interest rates are used. So you have to estimate the cash flows. That's your first task using the gamma distribution. Use the stochastic interest rate model. So you will have to find multiple interest rate using this information, and probably a good approach would be to have 12 different rates for each month, because we have monthly cash flows. The rate would be in annual terms, but you'll have to convert that to monthly for the purpose of finding the discounted value. Then you have to choose an appropriate rate of bonus suitable based on the consolidated expected present value if company wants to maintain a margin of 18%. So this is another piece of information that if we set up a simple equation of value, we have one component for the expenses, one for the revenue or the net cash flow as you want to take it. Then there is a component for margin, which is 18% of this EPV. And there is a third component, which is basically for the bonus. Now, there could be many assumptions here. This is where, you are allowed to choose, what your assumption is. You can choose to assume anything apart from these components is distributed as bonus, or you can calculate how much is the buffer, and from that you can suggest, okay, this is the bonus percentage which is more suitable within the range of the EPV that we have calculated as per the equation of value. So before we move ahead, I would like to know, we have few candidates in the class, so you can unmute the mic and speak to me. If you understand what I have explained so far, do you understand the gamma distribution, random value generation, then log normal, then setting up equation of value and profit margin? So these are 4-5 components of the whole exercise. So this was the part of business problem that we have understood. Then what we need to do here is to estimate those cash flow, as I have said. So EPV of revenue generated by each employee after adjusting the expenses. So this you can consider to be a net cash flow which is discounted back using appropriate interest rate. You need a consolidated EPV of the revenue generated by all the employees. So that means if you want to take all the revenues at one place, you can do that. Just calculate the EPV of all the revenue cash flows, or you can also do this as a net cash flow as well. So consolidated means it's not each month, but just added over the entire year. Then it is a histogram is needed. So this is one graphical representation that we need to do in the exercise. Once you have the EPVs, we are referring to the net EPVs here. You need to find the histogram and draw the histogram for the revenue, which is for employee per annum, each employee per annum, and then a proposed bonus rate maintaining the margin of 18%. So this is achieved through the equation of value that I'm talking about. Now, this was the explanation of the project that we have. Let's have a look at the data as well here. So this is our data, which is for 12 months, as you can see, and it is for, I guess, 14,729 employees. So you can see some cash flows are also zero, and all the other cash flows are positive. There is no negative revenue generated, assuming everything is good. Either they don't work, or if they work, it produces positive cash flow. Or even if there is a negative adjustment, it is not shown here. So these are all numbers which represent the revenue generated by each employee, which is linked to their performance. I have a proposed solution. Let me show it to you. So as you can see, this is a proposed solution that we have, and this is to, these are 14,729 records that we have. So these are some steps. I'm going to share this document in the group soon after the class. You can refer to it from there. And it also explains what are the steps that we are going to follow. So the first thing is that we arrange our data in an Excel sheet. So this is an Excel solution, but of course, as I suggested, you can do this using R or Python as well. Then you arrange the Excel sheet, you arrange the data in it, and expenses follow gamma. So you have to calculate the value for alpha and beta using this information, which is mean of 1354 and variance of 753. Using this information, you calculate what is the alpha and beta values. So once you have alpha and beta, you can use a inverse transformation or gamma inverse function to generate a random number, which is, or gamma inverse function, which is corresponding to a randomly generated value between 0 to 1. So why 0, 1? This is the inverse transformation technique that you have studied in CS1. And so we generate a random number, say 0.006. So what is the value of x corresponding to 0.006? Between 0 to 1 would mean we always get a value which is as good as probability, a random probability generated. And you can take a uniform 0-1 distribution here. Many packages, including Excel, allows you to generate a random number between 2 digits. So we can do that. We can use rand function to find a random value between 0 and 1. As you can see here, just typing rand also will give you that, because by default it takes between 0 to 1. And so this is your percentage point. Rand is your percentage point, alpha and beta are your parameters. When you use gamma inverse function, it will give you an x value which is corresponding to these alpha and beta calculated from the information given. Once you have the inverse value, then you have to adjust the expenses from the given revenue data to compute net cash flow per month for each employee. We already have the revenue information. Expenses have been modeled, have been randomly generated. We calculate the net cash flow per month each employee. So we have data for 14,729 employees and for each month. Then this is your net cash flow that is going to be used. So we then use the annual growth factors which are known, and they are known to follow a log normal distribution with parameters 0.075 and 0.01. So we follow the same technique again here to find a random interest rate. Now, when we use an inverse transformation for log normal, you must understand these are variance of, these are not mean and variance, these are parameters. So that means you don't have to convert it to mu and sigma. These are mu and sigma. So you can see here we have taken 0.01 power, whole power 1 by 2 or square root of that, and that becomes a sigma value. And we have calculated the interest rate as that log normal minus 1. So here there is a misprint, I think. No, it is correct, sorry. Because 1 plus I follows annual growth rate. 1 plus I follows log normal. We need the value of I. So I is calculated as log normal inverse value of that 1 plus I minus 1. Yes, that's correct. And these values could be negative. Now, because we are subtracting minus 1, and some values could be, lower than 1 also, and that would produce a negative interest rate. You should ignore that. And, you can also find another way to probably model the interest rate using this given information if you have. But this is one possible way, which has been used. You can ignore the negative rates and take only which are positive. You need to generate 12 different rates. So suppose the first month we have generated, let us say 0.008, which is 0.8% per month from this information. Then for all 14,729 employees, when we discount, we use that 0.008%, 0.8% per month, which may be translated from a bigger rate of, let us say, 10% or 11% per annum. So once you have the monthly interest rate for 12 different months, you calculate the present value, which is the expected present value, because we already have the adjusted expected cash flow. We are calling it expected because we have adjusted our gamma distribution from that. And this is how the histogram would look like, as you can see here. And this histogram, this is basically the present values or expected present values rather drawn here, and it produces a bell-shaped curve which indicates that the data is normal enough and the EPBs that we have. That means we can use inferential statistics and other statistical methods to forecast or identify missing quantities from that. But the task is not to go to that road. It's rather to use the principle of discounting and accumulation to find appropriate bonus rate. So we have information about the profit margin. We already have the consolidated EPV, and we can use this profit margin formula to calculate an appropriate profit margin, which has been given to us as 18%. So maybe the reason we have written this formula is just for understanding. All you need to do is set up a simple equation of value. The rest of the component that we have here in the equation of value, which could be used for the bonus rate. So once you have that value for bonus, which is the remaining quantity in the equation of value, if it exceeds, say, beyond 20%, then you can choose a rate between 8 to 20%. But if your answer is well within 8 to 20%, you can very well give that value. Now, the answer for every student, every participant may differ because we are generating random cash flows for expenses, and it is quite possible that your answer may differ from the other person. So, which means there is no specific answer for this particular project, and it all depends upon whether you are getting this range of bonus declaration as 8 to 20, and if your expected cash flow follow a histogram which looks like a normal curve. So this is this week's project, and I encourage you to use any software that you like, including R or Python. Although this solution uses Excel here, but this can very well be done within few minutes in R or Python as well. The idea is not to do this quickly or take more time, but to understand the logic behind it, how we are modeling the cash flows, how those cash flows are further being used to calculate the expected value, how to set up that equation of value and find the missing quantity. You can also use any other technique in Excel, or you can use Solver, or you can use any package in R or Python to do such work to find the missing quantity. However, I would really prefer you to follow the first principles and apply the knowledge and skill that you have from actuarial sciences into this. So I'm hoping that with this, information, with this session that we had just now and discussion about this project, you should be able to get going with it and try if this, if you're able to calculate the bonus rate. And whatever doubts you may have, you can always post them in the LinkedIn group as well. So that's about it. I'll take any questions that you have now. Feel free to ask anything that you'd like.